In this class, we evaluate here a very important triple integration over a unit sphere. Here the given that the region is the unit sphere. This is x square plus y square plus z square less equal to 1, and the integration is triple integration dx dy dz by x square plus y square plus z minus 2 whole square, and the answer is also be given here. Okay. Since the region or the volume of triple integration is sphere, so we make here a spherical coordinate transformation, right? And which gives x, y, z to r, theta, phi, and the relation or the formula of transformation are given by x. This is equal to sin theta sin phi. Y, this is equal to r sin theta cos phi, and z, this is equal to r cos theta. Okay, this is the formula of transformation in spherical coordinate. Now we know that Jacobian of this transformation, that is del x y z by del r theta phi, this is equal to r square sin theta. This is we discuss details in the class of spherical coordinate transformation. The link of this class is also given in description box. Okay, and also since here the volume of integration is the whole over the sphere or unit sphere, so the range of integration are also given by the range of r is 0 less equal to r less equal to 1. This is the radius of the sphere. And 0 less equal to theta less equal to pi, and 0 less equal to phi less equal to 2 pi. We also discussed about the range of this integration in spherical coordinate class. Okay. Now we put the value of x, y, z here, that is in the integrand, and we put the value of dx, dy, dz, that is the volume element, elementary volume element. This is equal to r square sin theta into dr d theta d phi. Okay. Now putting the value of x, y, z, write r dash, because r dash be the new volume of integration. Okay. And the integrand becomes, this is r square sin theta dr d theta d phi, and this term is given by, if we put x, y, z, then we get from the first two term we get r square sin square theta into, this is sin square phi plus cos square phi, plus we put here z, this is r cos phi minus 2 whole square. Okay, so we write here r, this is equal to 0 to 1, theta, this is equal to 0 to pi, phi, this is equal to 0 to 2 pi, r square sin theta dr d theta d phi, by, from here and here we get clearly, this is r square, and the second term is 4r cos, this is theta cos theta plus 4. Okay. Now we integrate with respect to phi first, because the integrand is independent of phi. So from this term or this range, and for d phi we get here 2 pi. Okay, because the integration of d phi is phi, and putting the range from 2 pi to 0 we get here 2 pi. So we delete this integration from this. Okay. Now to integrate this term we put r square minus 4r cos theta plus 4, this is equal to p. Okay, and here we integrate with respect to theta first, that is here we take r is constant, so we get, this is equal to minus 4r into the derivative of cos theta, this is minus sin theta d theta, this is equal to dp. So we put here r this is equal to 0 to 1 and theta, this is r sin theta. The value of r sin theta d theta, this is equal to dp, that is we get dp by 4 here, because this is r sin theta d theta, this is equal to dp by 4 and 1 r extra we remains r unchanged here, and this term is p, and we get here dr, because we cannot integrate here r directly, because in p there be the term of r. Okay, so by integrating with respect to p, we get 2 pi integration r, this is equal to 0 to 1, this is r dr, because r dr here, and by 4 we write the 4 outside of the integration, and from this term we get log p. And the range of the integration, what is the range of the integration? This is not theta, this is the range of p, where theta this is equal to 0. Okay, theta this is equal to 0 here, then p this is becomes r square minus 4r plus 4, because cos 0 means 1, so we get r minus 2 whole square. We put the lower range is p equal to r minus 2 whole square, so r minus 2 whole square, this is the lower range. And when we put this is pi, then theta equal to pi, then p this is equal to r plus 2 whole square, because we get r square plus 4r plus 4, because cos pi this is equal to minus 1, so we get the upper range is r plus 2 whole square. Okay, now by putting the range of this integration, we get pi by 2 into integration 0 to 1 r into log r plus 2 whole square minus log r minus 2 whole square into dr. Okay, and we get 2 terms from this and this, and this integration can be written as pi by 2 into integration 2 into r log of r plus 2 dr minus r log of r minus 2 dr. We take here also integration, and we take the common 2 from both the integration, because in this range in 0 less equal to r less equal to 1, we must have 2 minus r greater equal to 0, so the log is defined, otherwise log is undefined. Okay, we open the mod and changing the sign of this term. Now we integrate these 2 terms by integration of parts and get the result as pi into the first term is, we take this is the first function and this is the second function, so the first term is r square log r plus 2 by 2. Okay, and the first term of this is also given by r square into log of 2 minus r by 2, and the range of both the term are 0 to 1, and the second term is minus integration 0 to 1, this is given by r square by r plus 2 into here half, because the integration of log r plus 2 is 1 by r plus 2 and the derivative of r is r square by 2, and in the second term we get the integration of the derivative of log 2 minus r is, this is 2 minus r also, but here is another negative sign because here 2 minus r, so we get the positive sign because we get another one negative sign for the rule integration by parts. Okay, and the upper term is, this is r square, and also we get a 2 in the lower portion, we write already here, and this is dr. Now by integration by parts, we get the value of the integration is given by the first we write pi here common, and the first term of this integration is given by log of r plus 2, this is first function, into r square by 2, this is second function, minus integration 0 to 1, and we get the derivative of first function, this is 1 by r plus 2, and integration of second function, this is r square by 2 dr, and the range is 0 to 1. And for the second term, we get r square by 2 into log of 2 minus r, the range is 0 to 1, and this is plus integration 0 to 1, this is 1 by 2 minus r, so this is minus here because we get here another extra minus 1 for 2 minus r, okay, and r square by 2 dr. Now putting the range here and here, we get pi. From here we get this is half into log 3 minus 0, because if we put r equal to 0, then total term is 0. And from here we get, if we put r equal to 1, then log of 2 minus 1, this is log 1 equal to 0, and if we put r equal to 0, then this term is also 0. So the contribution of this term is 0 here, and we get another 2 term remains in this term. So we adding these 2 term as half into integration 0 to 1 r square 1 by r plus 2 plus 1 by 2 minus r dr. So we get pi by 2 into log 3 minus half into integration 0 to 1 r square, and if we add these 2 terms, then we get this is 4 minus r square, and the upper term is 4 dr, right? So we get here pi by 2 into log 3 minus 2 into integration 0 to 1, this is r square by 4 minus r dr. We write this term is positive, so this is negative, and we write the numerator as 4 minus r minus 4. Okay, so this integration can be written as pi by 2 into log 3 plus 2 into integration 0 to 1, this is 1 minus 4 by 4 minus r square, this is r square dr. Okay, this is r square dr, and the formula of this integration is given by integration this is dr by a square minus r square, this is equal to 1 by 2a into log of mod a plus r by a minus r. This is the formula of integration for this integration. Okay, so we get this as pi by 2 into log 3 plus 2 into pi. Here we miss a pi, this is also a pi, here also a pi, because pi is product overall the total term. So we get the integrating, we get r the first term, and this is 4 by 4 because here a equal to 2, so 2a equal to 4, and this is log of mod 2 plus r by 2 minus r. Okay, and the range is 0 to 1. So by putting the range, we get the value of the integration is pi by 2 into log 3 plus 2 pi into, this is 1 minus, because this is 1 where we put 1, and this is log of 3. Okay, and by calculating this term, we get by taking common pi from here and here, we get as pi into half log 3 plus 2 minus 2 log 3. So this is pi into, this is 2 minus, this is 3 by 2 log 3, and this is our final answer of this integration. Okay, so we write here the final answer. This is pi into 2 minus 3 by 2 log 3, and this is the result of the integration. We have to record it. Okay, this is very important type of problem, and this is very important for your upcoming exam also. Thank you for watching.